In 1964, a 17-year-old student stayed awake for 11 days straight just for a school science project. What happened to his brain along the way is the reason this experiment will probably never be allowed again. But you don't need 11 days. You don't even need 3. Because there's a specific hour, and it arrives sooner than you think, where your body quietly stops behaving like yours. By hour 24, you'll be legally impaired. By hour 36, your emotions stop obeying you. And somewhere past hour 60, your brain starts inventing things that aren't in the room. This is what happens to your body without sleep, hour by hour. Let's decode it. Hour 0. You decide tonight you're just not going to bed. To understand what's coming, you need to know what sleep was actually for. Because it was never rest, it was maintenance. Every night your body runs a repair shift it cannot run while you're awake. The first night it's easy. Coffee helps. Your body clock fights back with waves of sleepiness around 3 to 4 a.m., but they pass. Those waves aren't random. Your internal clock releases alertness in a rhythm, and between 3 and 5 a.m. it hits its lowest point of the entire cycle. If you survive that window, you get a strange reward. By sunrise, something strange happens. You feel fine, almost great. That's your body releasing extra cortisol and adrenaline. Emergency chemicals. It thinks something is wrong, so it's carrying you. This is the most dangerous feeling of the entire timeline, because feeling fine and being fine have now separated. Your body is writing checks with borrowed money, and the bill is already being calculated. Hour 24, 1 full day awake. Your reaction time is now similar to being legally drunk. Studies show 17 to 19 hours awake impairs you about as much as alcohol at the legal driving limit. And you're well past that. And caffeine can't rescue this. It blocks the signal that tells you how tired you are, but it does nothing to the impairment underneath. You end up alert and dangerous at the same time. And here's the cruel detail. Alcohol comes with a warning label built into your own head. You know you're drunk. Sleep deprivation removes the part of you that would notice. Your brain starts sneaking in microsleeps, 2 to 10-second blackouts with your eyes open. You don't even notice them. Think about what that means on a motorway. At 100 kilometers an hour, a 4-second microsleep carries you the length of a football pitch with nobody driving. This is why sleep deprivation shows up in crash statistics next to drunk driving. It isn't a character flaw, your brain simply takes what you refuse to give it. Hour 36. Night 2. This is where your emotions come off the rails. Brain scans show your amygdala, the fear and anger center, firing about 60% harder than normal, while the calm, rational part loses its grip. Researchers describe it as a disconnect. The gas pedal of emotion is pressed to the floor, and the brake line has been cut. Everything you feel arrives at full volume, with nothing to soften it. Translation: you cry at a commercial, you rage at a slow door, everything feels personal. And your judgment quietly breaks in a very specific way. Sleep-deprived people don't just make more mistakes, they become worse at noticing that they made one. Your body temperature drops, you feel cold in a warm room, chills in the middle of the day. Hour 48, 2 full days. Your immune system is now quietly failing in the background. Even 1 week of short sleep measurably drops your natural killer cells, the ones that hunt viruses. After 2 days of zero sleep, you are an open door. There's a study creators love to quote here. Volunteers were given a flu vaccine after restricted sleep and produced less than half the antibody response of rested people. Same needle, half the protection. Your hunger hormones flip too. Ghrelin, the eat now signal, surges. Leptin, the you're full signal, fades. And it isn't random food you crave. Studies consistently find the pull shifts toward sugar and fat specifically. A tired brain doesn't want a salad. It wants fuel. It can burn in seconds. That's why an all-nighter ends with you eating cold pizza at 4 a.m. and still feeling hungry. Your blood sugar handling gets worse too. After a few nights of poor sleep, healthy young volunteers process sugar so badly that researchers describe their results as pre-diabetic, from sleep alone. And this is where most people quietly live. Not 3 days awake, but 5 hours a night for years, collecting the same damage in slow motion and calling it normal. Hour 60. And now, the strange part begins. Your brain, desperate for rest, starts forcing pieces of dream sleep into your waking hours. The wall breathes. Shadows move. You hear your name in an empty room. It usually starts small and almost polite. A coat on a chair looks like a person. A rug pattern crawls. Your brain is filling gaps with guesses, and the guesses are getting bolder. In the 1964 experiment, the student became convinced a street sign was a person. By day 4, he believed he was a famous football player. He wasn't. This is the part people find hardest to believe. So hold on to this. He wasn't mentally ill and he wasn't on anything. He was a healthy teenager whose brain had simply run out of a resource. Any brain will do this. Hour 72, 3 days. Your brain is now officially running on fumes. Memory stops recording properly. You lose whole conversations. Simple math feels like advanced calculus. That memory failure has a precise cause. New memories are written during deep sleep. Skip the writing shift, and the day you just lived never gets saved properly in the first place. Speech slurs. Words come out in the wrong order. Your hands shake, and your eyelids weigh a ton each. Here's what's actually happening inside. All day, a pressure chemical called adenosine builds up in your brain. Sleep is the only thing that clears it. 3 days in, you're basically underwater in it. Caffeine doesn't remove it, it just puts tape over the warning light. That's worth sitting with for a second. Caffeine doesn't give you energy. It blocks the receptor that tells you how tired you are. The tiredness kept accumulating the whole time. It just couldn't reach you. Which is why the crash, when it comes, feels so violent. You didn't avoid the debt. You just stopped being able to see the balance. And every night you stay awake, your brain misses its cleaning shift. During deep sleep, spinal fluid literally washes waste proteins out of your brain. Skip it and the garbage piles up. One of those waste proteins is beta amyloid, the same protein that accumulates in Alzheimer's disease. Researchers are careful here, and so am I. This is a link under study, not a proven cause. But it's why sleep science stopped being a lifestyle topic and became a medical one. There is one genuine emergency tool, and it isn't coffee. A 20-minute nap clears a measurable amount of that pressure chemical without dropping you into deep sleep, which is what leaves you groggy. 20 minutes, not 90. So how does this story end? For the record holder, surprisingly okay. He slept 14 hours, then 15 the next night, and mostly recovered. But recovery has a shape most people get wrong. Your first night back, you don't just sleep longer. Your brain rebalances what it takes, grabbing deep sleep first and dreaming intensely later. It repays the most important debts before the rest. And that's also why one good weekend can't undo a bad month. You can repay a night. You cannot repay a habit. Because here's the good news. Your brain is astonishingly good at emergency repair. 1 or 2 full nights of real sleep, and most systems come back online. But the long game is different. Chronic short sleep, 6 hours or less, night after night, quietly raises your risk for almost everything you're afraid of. And that is a video of its own. So if you take one thing from all of this, take the boring one. Same wake-up time every day, including weekends. Your body clock cannot be argued with, but it can be trained. So tonight, when your brain asks for sleep, maybe just say yes. If you learned something, subscribe, because we're decoding the whole body one system at a time. And next, we're finding out what happens when you quit sugar.